divisibility rules, and others of you might be thinking, ooh, what is that? So we're going to go ahead and find out. We're going to learn all about divisibility rules. First of all, we need to know what is divisibility. Divisibility just means that after you divide something out, there's no remainder left. So in other words, it divides evenly in there. You're not going to have any leftovers, remainders, decimals, anything. It's going to be an even divide. So our divisibility rules, they're just shortcuts to tell when a number can be divided by another number where there's going to be no remainder. And believe it or not, we're going to use this a lot throughout the entire year. Especially in this unit, we're going to use it with prime factorization. But throughout the year, I'm going to be referring to, hey, can we divide it by 2? Can we divide it by 5? Can we divide it by 6? And you're going to want to recall this lesson. So here we go. Sometimes we find a big number like 356,821. And we don't know a whole lot about it. I don't know what the factors are of this number. But because I know my divisibility rules, I can tell you if it's divisible by 2, 5, 10, 3, 9, or 6. So we're going to learn the rules for all of those different numbers so that you too will be able to at least have a place to start, figure out what you could start dividing that by. So we're going to start with the easy ones that you probably are familiar with and move on to the ones that are probably a little bit newer for you. So the first one is divisible by 2. We can tell that a number is divisible by 2 if that number is even. Remember, numbers are either even or odd, and if it's an even number, we know it's going to be divisible by 2. So if we quickly look here, we've got the number 18, and all we're looking for is this last digit here, 8. 8 is an even number, and so we can divide it by 2. When we do, we get 9 with no remainder left. 22, again, we have just this number that we're concerned with. It's a 2. We know that 2 is in fact an even number, and so when we divide it by 2, we're going to get 11 with no remainder. So notice that both of those numbers were even. If we look down here at this last example, 21 is our number. So we're looking here, and we're looking to see if it's even or odd. Remember, even numbers are 0, 2, 4, 6, and 8. This is not one of them. It's a 1. That's an odd number. Therefore, I can't divide it by 2 without getting a remainder. So we would say it is not divisible by 2. So now let's check. Are these numbers here going to be divisible by 2? We can do that really, really quickly. Remember, all I'm going to do is look at the last number for each one of these numbers. When I look here, I'm looking at this 7. I know that 7 is an odd number. So no, it is not divisible by 2. Again, 937, a big number, but all I need to look at is that 7. And again, no, it is not divisible by 2. The very last one, 4,678. I look at that 8, and sure enough, that's an even number. So I know that if I wanted to divide this by 2 to get it smaller, it would work and I wouldn't have any remainders left over. So divisibility by 5, that's another one that a lot of people are familiar with. We know that a number can be divided by 5 evenly if that number ends in a 0 or a 5. So again, we're looking at just that last number, and if it's a 0 or a 5, we know that it's going to work. So we look here, we've got 25. I look at that last digit, it happens to be a 5, so I know, yes, it will, in fact, work. This next one, 23, I got a 3 at the end, and my rule states that I need a 0 or a 5, so this one is not divisible by 5. 23 is not going to work. Let's go on to 10. A lot of you know this one as well. It's very similar to the last one. We know that a number is divisible by 10 if it ends in a 0. So again, we're just looking at that last digit, and if it's a 0, the answer is a yes. So let's look here. We've got 30. 30 ends in a 0, so this one is a yes. It is divisible by 10. We have 340. The last digit's a 0, So again, we know that we're going to be able to divide it by 10. 67, ooh, that 7 is not a 0. This one is not divisible by 10. We got a remainder. And same with this last one. The last digit is a 4. So that one's not going to divide evenly. So 2, 5, and 10, the easier ones, you probably are familiar with them. Let's check out what we have next. Number 3, we can figure out if a number is divisible by 3 if the sum of the digits is divisible by 3. Well, what does that mean? Sum, we learned earlier in this unit, just means the answer to addition. So if the sum of the digits adds up to equal a number that's divisible by 3, then I know the whole thing's going to be divisible by 3. So let's check it out. Is the number 135 divisible by 3? We're going to take this 135 here, and we're going to break it down into 1 plus 3 plus 5. When we do that, our answer is 9. Is 9 divisible by 3? Can I take 9 divided by 3 and get a whole number for an answer? Yeah, 9 divided by 3 is 3. Therefore, 135 is divisible by 3. 6. Again, another one that's probably unfamiliar to you, but it's not a very difficult one. This one simply relies on you testing out the other numbers first. If you go through and find out that a number is divisible by both 2 and 3, then we know it automatically has to be divisible by 6 as well. So let's check it out. Is 42 going to be divisible by 6? Well, let's check it out. If it's divisible by 2, we look at this last number, and it's even, so we know that it is in fact divisible by 2. Is it divisible by 3? Remember, we need to add up the digits. So 4 plus 2 is 6. 6 is divisible by 3. So this one happens to be divisible by both 2 and 3, which means that, yes, it is divisible by 6. So let's try this one out. 51, is that divisible by 2? No, it's an odd number. I can go ahead and stop because it has to be by both 2 and 3. We know it's not divisible by 2, so it is not divisible by 6 either. Divisibility by 9. This one is just like 3. A number is divisible by 9 if the sum of its digits is divisible by 9. So just like we did with 3, we're going to take the digits, add them up, get the sum, and see if that number is divisible by 9. 369 is my question, so I'm going to take 369 and turn it into 3 plus 6 plus 9. When I do that, I get 18, which 18 is divisible by 9. Or for some of you, when it gets to be a big number, you can continue to break it down. 1 plus 8 equals 9. So therefore, we know that 369 is in fact divisible by 9. So now I have a few questions for you to go ahead and try out. I want you to use your divisibility rules to tell me what the following numbers are divisible by. Looks like I have my page is a little off, so I'm going to move it over here for you. There we go. That makes it a little bit easier. There we go. So what I want you to do here is I just want you to go through and start with 2. Is it divisible by 2? 2,958. Is it divisible by 2? Well, this last digit is an 8. Therefore, I know it's even, so yes, it's going to be divisible by 2. I'm just going to write a 2 there. Then I'm going to go on to the next one. 3. How do I figure out 3? Oh yeah, I've got to add up all the numbers and see if that number is divisible by 3. So when I take 2 plus 9 plus 5 plus 8, what do I get? 2 plus 9 is 11, plus 5 is 16, plus 8 is 24. Is 24 divisible by 3? Yes, it is. 3 times 8 is 24. So 3 is also one of my numbers. How about 5? Is it divisible by 5? Well, my last number is an 8, not a 5 or a 0. So 5 is not going to be one of my choices. How about 6? What was the rule for 6? Both 2 and 3 has to work. Well, 2 and 3 is what we have down, so I can automatically put my 6 there. I'm going to erase this so it's not in the way. So let's move on. 6, after 6 we have 9. Is it divisible by 9? Well, we had, when we added up 2 plus 9 plus 5 plus 8, it equaled 24. Is 24 divisible by 9? No, that one's not going to work. And how about 10? It doesn't end in 0, so 10 isn't going to work. So 2,958, using our divisibility rules, is only divisible by 2, 3, and 6 of the different ones that we know a rule for. I want you to do the same thing with these last 4, and we'll talk about it in class tomorrow. Have a great night.